I am happy to have Automotive Seminars as a sponsor for the show. Now, if you're not familiar, Automotive Seminars is a diagnostic technician training company. They've got a website that there'll be a link to in the show notes. And what they offer is top-notch training to technicians like us in the field. I've been taking their training courses for years and have got a ton of benefit out of it. They've got top-notch instructors, John Thornton, Scott Shotton, Scott Manna, and every other month they've got a 2-night course that you can sign up for. Join in, ask questions, and afterwards, you've paid for the course, you can access a recorded version whenever you want. You can rewatch the class 2 years later in case you wanted some details on it. And that is a fantastic feature. So make sure to check out the website to see what courses they have available and what's coming up in the future. This podcast is brought to you by Jarhead Diagnostics. Jarhead Diagnostics manufactures in-house diagnostic equipment and storage solutions, as well as distributes for companies like Pico, ATS, and TopDon. One of my favorite tools that I've bought from Brandon and Jarhead Diag is the case for the U-scope. If you don't have a U-scope, you probably should, but if you have one, you got to get one of these 3D printed cases, has a magnet on it, has a full-size BNC lead that you can connect to, and it gets rid of the weak point of that scope, which is the mini BNC connection, which is pretty fragile. This case makes this thing nice and secure and makes it an even better tool than it was. So check out jarheaddiag.com. The link is in the show notes. This episode is brought to you by L1 Automotive Training and Keith Perkins. If you're looking for education on module programming, J2534, EEPROM work, key and immobilizer, electrical diagnostics, or drivability diagnostics, Keith has a website, l1training.com, that's got over 60 hours of training videos on all those subjects and more. When I first started out doing mobile, I utilized Keith's videos on module programming in J2534 in order to get my head wrapped around what I would need for the tooling, the computers, the software setups, what kind of obstacles I would be up against when I'm out there programming modules on cars. And it was a huge benefit to me. And I continue to use the training videos that he has on his website. So I strongly recommend checking out l1training.com. We have got Auto Rescue Tools and Isaac Rodell as a sponsor for this podcast. Hey guys, if you're looking for programming laptops, you want the laptop set up ready to go for programming control modules on vehicles, you need key cutting equipment, you need diagnostic tools, Isaac is your guy. Has all that stuff available for purchase, and the support that he offers along with the purchase has been outstanding. I bought some stuff from him in the past. I got my Dolphin key cutting tool from him several years back. And again, the support has been phenomenal. Helped me out along the way with anything additional I needed to make it work for me. Also, for the month of June 2023, they've got Autel updates for sale. So make sure to check that out as well. Again, that's autorescuetools.com. The link will be in the show notes. Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and it's just me again for this week, but I got a few more case studies here for you. I've got some interviews lined up in the near future, get some other people on here, but you're stuck with me this week, so let's get into it. Here's what I want to talk about this week. I'm sure it's something that all of you are familiar with, but it deserves a little bit more conversation, I think.
just so that it's top of mind while we're going into everyday life as technicians, right? What I'm going to be going through today is what I feel is a surge in poor quality replacement parts. Okay. So I'm talking about a new part you put on a vehicle after you've made a diagnosis already. You've already condemned a part for one reason or another. You put a new part on, not necessarily a used one. A used one might be better in some instances here, but you put a new part on you've purchased from some vendor, be it aftermarket or even sometimes dealerships. And after you put on that new part, it still has the same problem or maybe a different problem, but the worst is when you have the same problem as the one you replaced it with. And I'm running into this all the time doing my mobile work. It feels like the last few weeks or maybe a couple months, that's like all I've been telling shops is, yeah, this third part that you've put on here is failed. And they're at their wits' end because they've lost all confidence in their ability to diagnose the problem, because every part they put on there, they end up with the same issue, the same problem. And that does get really difficult for us as technicians. We second guess ourselves. We second guess our testing procedures, what we think is normal for the system, how we assess that a component failed when every part that we put on there gives us the same issue, right? So how do we get past that? It's kind of what I want to talk about today, is giving you some examples of how we can be confident in understanding how the system works and our testing procedures, our test results, to say for sure, yeah, this is the third junk part that we put on this vehicle. So that out of the way, I'm going to give you 3 case studies, and actually before we get into the case studies, I was going to talk about just modules in general. I don't have a specific case study for control modules, but that's kind of the way we can start this off, is that I'm seeing a ton of control modules that are junk either right out of the box or shortly after. One that comes to mind right now, it's actually a vehicle at a transmission shop that I go to, is the Ford Fiesta and the Ford Focus with the automatically shifted manual transmission. The TCMs in those things are extremely prone to failure. Ford had some big recall on them. I've done so many in the last few years, all the time, but the actual Ford modules are on intergalactic back order. You just can't get one. I don't even know if the Ford dealerships can get them, if they're hoarding them, but they're nowhere to be found. However, if you go onto eBay or other websites, I don't know where, I know a few of my customers have purchased these TCMs from eBay. They get these modules, and I've done 2 or 3 of them now where they're either failed right out of the box, like they won't even program. That's the couple that I've run into, or they program and then they fail almost immediately. They'll do the learn procedure. The customer goes out and drive it, and it's an immediate failure. And I got one sitting at a transmission shop that's been there for at least a month, if not more. They're just waiting on a Ford module, and they have no idea when they're going to get one, right? So I guess that's just going to show that modules in general are having a trouble with the chip shortage and everything. But just getting a quality replacement part is pretty difficult. Personally, I think this, at least for the foreseeable future, is going to bring used parts, back into focus, because it actually kind of makes sense now to recycle some used modules, even though auto manufacturers haven't really made it the easiest for us to do that. There's some really smart people out there that can still make it happen, maybe with some, backdoor methods to get a used module to work. But that's the best option for repairing certain vehicles right now. Anyways, that's kind of its own thing, the whole module thing, but I'm seeing that a ton, right? Where you put a module in, it won't program right, or it doesn't do what it's supposed to, or it creates a new problem that we didn't even have before, from some of these remand or I don't even know where they come from, modules. But anyways, let's get into the case studies here, because the case studies actually don't have anything to do with modules. I just wanted to touch on that before we jump in. The first vehicle that I wanted to talk about was actually 3 different vehicles in the span of 3 weeks, but they're all very similar. So I'm going to lay this out for you to understand what I'm talking about. It's 2008 to 2010-ish Dodge Charger or Chrysler 300. 2 of these were Chargers and 1 was a 300. They all had V6 engines, so I don't know if this applies to the Hemi style. It might. I'm not 100% on that. But all 3 of these vehicles had fuel pumps replaced for no fuel pressure. Okay, so the shop diagnosed that there was no fuel pressure, fairly easy diagnosis to make, and they determined that the fuel pump was at fault. Okay, so the fuel pump on this one, it's a saddle style tank. So there's actually 2 sending units on each side of the vehicle, each side of the tank, but the actual electric pump is in the driver's side of that saddle tank. You pull up the back seat, pull the cover off, and then you can access that pump. There's a long tube that goes in between them. Each side has a level sensor, pretty common setup. But anyways, the pump that I'm referring to is on the driver's side. And so the first one that I got called into, they said, yeah, we've got no fuel pressure in this thing. And we replaced the fuel pump and there's still no fuel pressure. And we're really not sure where to go. Because they're assuming the part they put in there was just fine. You know, it's a brand new pump and we have the same symptoms. We must have missed something. So could you come take a look at it? Sure. And I verified very quickly that yes, there was no fuel pressure going to this engine. So first thing I do, they actually had the back seat out. I went right to the pump connector and it's got 4 wires, 2 for the pump and 2 for the level sensor. And so all I'm looking for here is power and ground to the pump. It has a constant ground. It receives power from a relay that's located in the power distribution center in the trunk of the vehicle. What I did was I used my scan tool, left the key on, and I went into the bidirectional controls for the PCM and I turned on the fuel pump. There's a toggle feature that you can use for these Chrysler vehicles where it will turn on and off, on and off. And I'm going to plug in my test light, or I could use a headlight bulb if I'm questionable, but I plugged in my test light across the 2 wires for, you know, power and ground of the fuel pump, and the light lights up. Okay, so I know something's happening there. And again, I could utilize a headlight bulb, a 9000 series headlight bulb here to verify that the circuit can handle the load. But my test light was lighting brightly. And so I'm like, okay, well, everything is here. And my first thought was maybe this is just a junk pump right out of the box. Okay. That's kind of what we're talking about here on the episode. But this actually has happened to me 3 times in 3 weeks now. But at this first one, I wasn't aware of that. So what I decided to do was pull out the fuel pump from the tank and just to check it out and see, you know, was something left unplugged? Was there anything going on with this pump? Is there something I'm missing between the connector at the top portion of the pump and the actual pump itself? Because think of a fuel pump module assembly. The actual electric fuel pump is down in the lower portion of the module assembly where the strainer is. And then there's a short sub harness or wiring that goes from the pump up to this top plastic piece that actually, you know, is retained on the top of the tank. And that's where the plug-in is. Okay. And so there is a short piece of wiring between that piece and the pump, but you can't see that unless you pull the pump out. So that's what I did. I pulled the pump out and I wanted to take a look at this. And everything seemed to be plugged in and everything, but I was looking at the connector that plugged into the top of the tank, and I was looking at the connector that went from the top piece of the tank down to the pump. And I noticed that the 4 wires that were present on this connector, there were 2 of a larger gauge wire, and then there were 2 of a smaller gauge wire. Okay. And on the harness side, the vehicle harness side, the 2 larger gauge wires were right next to each other. and the two smaller gauge wires were right next to each other. Okay, so the larger gauge is for a load. It's for the fuel pump. It takes current. The smaller gauge wire is for the level sensor. We're just talking about voltage. We don't need to send current. So they change the size of the wires according to what the circuit needs to do. But on the pump side, okay, so after we're now inside of the tank going down to the pump, it went large, small, large, small. So the two large wires were no longer next to each other on this connector, meaning that one of the wires that we were sending, I think it was ground to, was actually going to the level sensor. And what was supposed to be feeding power to the pump is hooked up to the circuit on the car side that's for the level sensor. So of course the pump's not going to run here because it doesn't have power and ground. I think it had power, but it didn't have a ground. And the level sensor is now connected into the driver circuit for the fuel pump. Well, of course the pump's not going to run. So what I did in this case, I actually tried depinning this thing, and it was an absolute nightmare. I could not get the pins out because I was just going to move the pin one over on this connector. It's like a little sub harness on the fuel pump. I was just going to move the pin over one. I don't know. I fought it for like 5 minutes and I'm like, okay, screw this. So I just unplugged it on the top portion of the fuel pump. And then I unplugged it on the pump and the level sensor. I swapped out the old one because they actually did have the old pump for me. Plug that in, the pump runs immediately. It's good to go. Okay, so that one was solved, but this happened to me 2 more times within 3 weeks. And I'm like, what the heck's going on? And I asked the shop owners after the second one. I was like, where are you getting these pumps from? AutoZone. Okay. And not to bash on AutoZone. Who knows where they get it from, right? The supplier's probably any place. But the third one that I went into, it's a Chrysler 300, no fuel pressure. We just replaced the pump. I'm like, okay, I know exactly what to do. So, I walk in there and I look like, I have a crystal ball or something because I walk right back to the pump. I pull it out. I'm like, yep, here you go. But I'd seen it a couple times already. I'm like, where'd you guys get this pump? Was it AutoZone? Oh, how'd you know? Okay, so it looked like they maybe had a bad supply, but for everybody else out there, I guess watch out for it. If you're getting an aftermarket pump, those sub harnesses between the top of the fuel pump and the fuel pump itself are wired in correctly. And again, 3 times in 3 weeks. So whether it was a bad batch or, something is just up with that era of vehicle, I don't know, but keep an eye out for it if you're installing fuel pumps on those things. So the fix was just to correct the wiring and it was good to go. The pump ran. Okay, so on to the next one. This is a 2007 Chevrolet Equinox, has a 3.4 liter V6. This thing still has an EGR valve. We don't see a ton of EGR valves on gas motors anymore, but this one has one. This is an old pushrod motor with plug wires, getting pretty outdated for 2007 even. But the shop had just replaced the EGR valve for P0404, which is open position performance for the EGR valve. Well, after they replaced the valve, they got the same code. So they called me to come check it out. They said, well, maybe there's a circuit issue, maybe there's an ECM issue, but we want you to check it out and you let us know, what we need to do. So I get into this and I verify, of course, the code is present. And the open position performance for the EGR just means that when the EGR is commanded open, the computer does not like what it sees from the position sensor. Okay, so it definitely could be a circuit code, but let's get into this and see what we've got going on. I graph the EGR position and I put the vehicle into gear because you can't just rev these things up, at least on GMs. They won't activate the EGR valve unless you're under a load. And so I would put it into drive, power brake the vehicle. I could see the EGR command go up. And as soon as I did that, I watched the position sensor and it would jump like erratically between almost closed to fully open. And you could actually feel it. As the engine was trying to accelerate, it would start to chug like it was misfiring and stumbling as you were doing that. It kind of felt like, an EGR was open when it wasn't supposed to. And I think that's what was happening based off of what I saw on the scan tool. So obviously we definitely have an issue here, but the fact that the engine actually chugged and ran poorly makes me think that the position sensor that's showing rapid movement up and down is reading accurately, right? That there's actually, you know, something going on that's keeping that valve open or forcing that valve open more than it normally would be. Because if it was just a sensor or circuit issue, I mean, it could still be a circuit issue for the solenoid side, but if it was a circuit issue for the sensor, the engine wouldn't run poorly. And in this case, it definitely feels like the EGR is open more than it's supposed to be. And I'm seeing that reflected in the way the engine's running and also the position voltage that I'm getting through the scan tool. So I'm going to go to the valve and inspect. There's 5 wires on this thing. 3 are for the potentiometer, which is the position sensor of this valve. And the other 2 are for the solenoid, which actually moves the valve and causes it to open up when the computer commands it to. And it's going to pulse width modulate the circuit in order to do this. There is a constant ground to this solenoid, which is fed by the PCM. And then there is a pulsed power source, which is going to be duty cycled by the PCM in order to open up the valve a certain percentage. Okay. So pretty standard stuff. I'm sure most of you are familiar with how this works. So what I did in this case is I want to make sure that the command to this solenoid didn't have some sort of issue. Because like I said, it was opening up way more than it should have been. And I want to make sure that the computer is commanding this thing correctly. So I checked for the ground, and the ground is constant. It's always there. There's no issue. But what I did was I scoped the power source to the solenoid. And again, this comes from the PCM. There's a transistor inside of there is going to pulse width modulate the power source to the solenoid in order to get it to open a certain amount. And I can actually control the amount of duty cycle via the scan tool. I can give it a percentage, and I gave it 10%. Just like that should be barely open for this valve. And I watch it on my U-scope. And although it does register as a 10% duty cycle as far as the on time goes, the pattern did look really weird. And that's the best way I can describe it audio only. It wasn't a very clean square wave, which I thought was kind of odd, but it was a square wave, and it was about 10%. Now, here's the other thing I noticed when I turned it on and the engine's off and I'm just, you know, kind of sitting there on top of the valve listening to it. It sounded like it was clicking. And if you've ever tested an EGR valve, especially one that's pulse width modulated, they don't click. They'll almost kind of make a similar noise to like an electric throttle, where it's like almost a high-pitched whining noise. It's not exactly like an electric throttle, but it's similar to that because it should be being pulsed so quickly that the valve is not rapidly moving like up and down in its full travel, but it will actually hang open a certain amount. I mean, that's the whole purpose of pulse width modulating a solenoid very quickly, is so that we can get that valve to open a certain amount rather than being fully open or fully closed. But this thing sounded like it was clicking, like opening up fully and then closing fully at 10%, which is not right, but also is going to support what I saw on my position sensor in the scan tool. So what I did here, because this was super easy, it was 2 10mm bolts. I pulled the valve off, I left it connected, and I wanted to watch that pintle. And I did, and I watched this thing, and it's going up and down and up and down. It's full travel at 10% duty cycle. And I was like, well, okay, well, this is obviously not right. There's something wrong with the situation, because that shouldn't be happening. Now I was questioning, okay, is this just another failed EGR valve because it's the same code they had before, or is there a problem with the circuit? Now, how could there be a problem with the circuit to cause the issue that we're having, right? A valve that's moving too much from a 10% duty cycle. And I was like, well, if the percentage of the duty cycle is correct, the on time is correct, and we have good power and ground, we can't get a valve to move more than it's supposed to. It's just, that's not possible on the circuit side. It has to be something wrong with the solenoid itself. It has to be the wrong resistance compared to what the right resistance should be. And that valve is just moving too much from that 10% duty cycle. And I was thinking that has to be what it is. But let me just verify the circuit with something else in place besides the EGR valve. So I unplugged the EGR valve, I put my test light in place, and I also watched the duty cycle while I was commanding the solenoid on with my test light in place. And it lights up my test light just fine and it changes based on the duty cycle. The duty cycle also cleaned up significantly when I was using my test light instead of this solenoid. Now, I didn't do an amperage measurement of the solenoid, and maybe I should have, but I have a feeling that thing was drawing way too many amps for what was supposed to be in there. And again, making full movement of the solenoid at 10%, not what it was supposed to do. So at this point, I'm pretty confident. I tell the shop, get another EGR valve for this thing. The one you got is junk. So they do that. They get another EGR valve. They put it in, same thing. I'm like, okay. So he calls me up. He's like, yeah, it's doing the same thing. And I'm like, okay, well, let me come back out. I'll double check this, and maybe I missed something. And I looked at it, and it was setting the same code, but it was actually failing in a slightly different way. It wasn't opening up as much, but there was still movement if you looked at the position sensor on the scan tool. And so I went through everything again, condemned the valve again. Okay, this one's still not working the way it's supposed to. Everything checks out with the circuit. I told him, we need to try a different brand. He's like, okay. And we looked, the last two had been Delphi EGR valves on this thing, and which you would assume would be good, but he's like, I'll try a different brand. So he tries a different brand. He said, same problem. And I told him, I was like, okay, I'll check this out one more time. There's got to be something I'm missing. But between the time that I was able to get out there, he actually found an AC Delco valve. He put the AC Delco one in, and he called me and said, it's all good to go. There's no problems here. It was the valve. We just had to get a good one. So we had to go through 4 different valves in order to get one that worked correctly, which I think is ridiculous, but that's what we're up against out there, right? I mean, even myself, I'm second guessing my own testing procedures when you get 3 valves that are doing the same thing or something similar. So anyways, there was no problem with the car. It was an EGR valve, but on that model, make sure you get an AC Delco one, because apparently the Delphi and Eklund ones just don't function correctly for that application. So that's case study number 2. The final one I have for you today was a 2015 Chevy Sonic. And I was called to the shop to look at this Sonic because it was overcharging, meaning that the alternator was pumping that battery voltage up too high, and it was setting codes in multiple modules for high voltage. And the shop said it was up over 16 volts, which I did confirm. But they've also put in 3 alternators in this vehicle already. Now, the first alternator was put in at another shop, and then the customer brought it to this shop. So my one challenge here is I don't know what the original problem was with this Sonic. I don't know if it just wasn't charging and we built in this problem, or if the problem was always overcharging. And I still don't know to this point right now. I know we fixed it, but at that time that I'm looking at it, I don't know if this is the original problem or not, but I do know it is a problem. We're not supposed to be overcharging. So I'm going to look into this here. And of course, it's really common. I'm sure, again, most of you are aware of this, to get alternators that don't charge correctly with all the advanced charging systems that we have on vehicles now. It seems to be very common with aftermarket alternators to have issues. And so that's the first thing that's on my mind. But of course, my job is to check. And once a couple components have been replaced, or the same component has been replaced a couple times, I really want to, dot all my I's and cross all my T's on my diagnosis to make sure that I'm making the right call, because you can see it in these shop owners' faces when I tell them your third part is also failed. They're like, are you sure? And I'm like, well, I think so. But no, I want to be confident in this. So I need to understand how this system works. So let's go over this quickly here on this 15 Sonic, how the charging system works. And you may be familiar with it, but I want to go over it in case you're not. The alternator, fairly simple. It's got an internal regulator that's going to regulate the voltage for the system. It's got the big, thick cable that's actually, pumping out current to the system, to the battery. And then it's got a small 2-wire connector, which it's going to get instruction from the engine control module on what level to charge the system to. Okay. And on that 2-wire connector, we have an L terminal and an F terminal. And the L terminal is basically the duty cycle a pulse width modulated duty cycle from the PCM that's going to send a percentage to that alternator to charge to a certain point. And then the F terminal is the feedback back from the internal regulator on the alternator back to the PCM to say, yeah, I charge this much. So we have a duty cycle, a command, and then we have a feedback back to the ECM. And that's pretty much the setup, to actually run this alternator. But there is a little bit more to the system away from the alternator. Now, of course, you have the engine control module in control of actually changing the output level of the alternator, but the ECM, and I got all this from reading service information, the ECM is going to receive instruction about charging the system from the body control module. And the body control module is going to manage electrical loads on the system. And it's going to look at battery state of charge. It's going to look at, of course, the system voltage. It's also going to look at an inductive amp clamp. I guess maybe it's not a clamp, it's a sensor, but I call it an amp clamp that's around the negative battery cable. And it's going to look at the amount of amperage either coming from or going into the battery, depending on the situation. And it's going to take these things into account, and it is going to feed information to the ECM to say, hey, charge to this level, or adjust for this, up or down the voltage because of blank. So there's multiple modules that are involved in this system. And for something like this, where we have a weird overcharging problem, we want to take into consideration that there could be a problem with another module. Maybe the BCM does not perceive the system voltage correctly. And so it's commanding the PCM to, okay, go higher on this voltage because I'm not reading the system voltage correctly. That was kind of my first thought, is I need to look for that. And are all the modules reading the correct voltage level? Something to think about. Maybe the amp clamp, as I called it, on the negative battery cable is not installed correctly. Maybe we're missing a cable on there. Maybe it was taken off and not put on correctly, and the BCM is perceiving the charge out of the battery incorrectly. That's a possibility. There's a number of possibilities here, and we want to consider that as we go in. The other thing that's in service information for this vehicle was a chart that correlated the amount of duty cycle on the L terminal, that's the one from the ECM to the alternator. It correlated the duty cycle percentage to a voltage level. And this chart was actually really helpful for me in diagnosing this vehicle. Basically, the top end of the scale at 90%, you should be at 15.5 volts, which is, a little higher than some of us are used to when we think traditional charging systems, but, this is a newer vehicle. And then on the lower end of the scale, 10% would be 11 volts, and probably wouldn't see that too often, but it is good to know if that's what the PCM's commanding, we're going to have under 12 volts for the system. And I don't imagine it would keep it there for very long, but that's the fact of the matter, is that percentage on the L terminal, that's what the alternator is supposed to put out. I did note in this chart as well, if there's a fault in the L terminal circuit, meaning that the duty cycle from the ECM to the alternator has some sort of circuit fault, open, short to ground, short to power, whatever. The alternator or the regulator in the alternator is designed to output a constant 13.8 volts. And I've actually verified this on these models before. You unplug that connector, that alternator will put out 13.8 volts steady, as long as it's spinning, obviously. And that's important to know too, because if we had a fault in this circuit, that's what I'd expect to see. But for some reason, we're seeing a much higher voltage come out of there. And also, you can look at data pits in the ECM, and it does not indicate a fault for either the L or the F terminal, meaning I don't really need to go under to this alternator just yet to check it, because the ECM is showing this thing's plugged in. But again, why is it overcharging? Let's look at the data PIDs and see what we can figure out. So I'm looking at the vehicle, and when I rev this thing off of idle, I will get 16.8 volts when I get it just off of idle. Below that, we're sitting at 15 and some change, but just a small amount of engine speed increase, and we're getting 16.8, which is obviously setting our high voltage codes and obviously not a correct voltage for the system. So when I look at the duty cycle in the ECM for the L terminal, it started at about 70% when we're idling. And then as I rev it up, it drops to about 40%. And the voltage will eventually come down to about 14 if I hold it there long enough. But there's a decent period of time when the voltage is held up around 16 plus volts, and the ECM seems to respond by dropping the duty cycle, but it can only get it down to about 14 volts at 40% duty cycle. Now, if I look at my chart and I correlate what is the voltage supposed to be at a 40% duty cycle, it's supposed to be 12.7 at 40%, and it's not. The best that thing can do at 40% is about 14 volts. So that's too high. And of course, when I let it idle, we're sitting at 15 volts, and at 70 we're only supposed to be somewhere in between 13 and 14. So what I'm getting at here is the numbers that I see in the system are not correlating to the duty cycle output by the ECM. So that's my first concern, is that something doesn't match up here. So I did want to take a look, I'm kind of thinking alternator at this point, but I did want to take a look at the BCM just to see if there's anything going on in there where the BCM would be indicating a reason to charge more than needed. I mean, again, when we look at that duty cycle, something doesn't quite match up there. But I just want to, again, check everything before I'm ready to call this part. And maybe if it hadn't had 3 alternators, I probably wouldn't even gone this far, but I check all the data PIDs in the BCM, and there's actually a lot of useful charging information in the electrical portion of the BCM data PIDs. So if you're on one of these things, I mean, this would probably apply to a lot of GMs around this era. Check out the BCM. It's got a lot of interesting stuff as far as data PIDs go. You can look at battery state of charge. You can look at the amount of amps going in or out of the battery. And I did confirm that with an amp clamp to make sure that the amount that sensor was reading matched an actual amp clamp that I put around the negative battery cable, and it was accurate. It was mounted correctly. That was all good to go. But you can look at battery state of charge. You can look at a number of different data PIDs that indicate some sort of special charging scenario based on something like a sulfation mode or a cold startup mode. And there was a couple other ones in there as well. The one that I noted when I would rev up the engine and our voltage would jump up to 16.8, the BCM had a data PID that said voltage reduced request. And that would say yes once that happened. And that is when the PCM would eventually drop down that duty cycle to the alternator to get us to, again, to 14 or so, but at a pretty low percentage that didn't match up to the voltage that we were seeing. But where I'm going with this is the BCM appeared to be trying to lower the system voltage, or recognizing that, hey, something is not right here. Why is the voltage so high here? So I didn't see anything in the BCM that indicated an issue. And I did actually check in both the BCM and the ECM that they were reading the actual system voltage, within the data PIDs that matched what was on the system itself. Okay. That all matched up. So they weren't seeing an incorrect voltage. Both modules appear to be trying to charge the vehicle correctly, but it's just not happening. So the last thing I wanted to do was actually scope the L terminal to make sure that the duty cycle that was present on the circuit matched what the scan tool says. And I just use a scope, and you can actually measure the duty cycle or the frequency of a circuit. And I matched that up to what I was seeing on the scan tool, and it matched, right? So when we're at 70%, that was at 70% on the circuit. 40% was 40%. That all matched. So what the scan tool was telling me it was doing on that physical circuit. So at this point, the one other thing I could have done was unplugged the alternator and see what it charged at, but I didn't try that, mainly because it was a pain to get to the alternator. But at this point, everything checks out except for the alternator. That's what needs to be replaced. And again, I would have gotten there sooner hadn't it been for, 3 alternators that weren't replaced before. Of course, I did check the battery condition and made sure that there's not like a block ground issue and all that basic checks that all checked out. And again, I kind of went back and double checked everything on this one just to make sure. But I told the shop, I was like, hey, you got another failed alternator. That's it. So get another one, get a different brand, get an OE, whatever you got to do. This one's failed as well, even though the last one was overcharging as well. Again, I don't know if that's the original problem, but the last two that we've had in there for sure are overcharging. So they get an alternator, and the next day they call me up. They say, this thing's not fixed yet. I'm like, dang it. I must have missed something. I'll come back. So I come back, and I actually look at this thing, and it was fine. It was actually charging the correct voltage. And so I go in and I ask the shop owner, and he asked the tech, and apparently there was some miscommunication. I think maybe there was still a high voltage code present. I really wasn't, I didn't grasp exactly where the communication fault happened. I'm better with networks than dealing with people, I guess. But anyways, the car was fixed after that final alternator that they put in it. And I drove it around and I confirmed this. At least I was able to say for sure, yeah, this thing is fixed with this alternator. So we were all good to go there. But those are my three vehicles lately that I've dealt with. And it just seems like I'm ready for it on any vehicle that I go to, that, hey, this new part might be failed. And that's kind of why I wanted to talk about it for this episode, is just to keep it on top of mind for everybody. You're replacing these components. And of course, we want to try to get high quality components, when we're replacing things for our customers. But even when we try our best right now with part shortages and difficulty getting things from different vendors, you don't really know. And it just seems to be happening more and more often. So be aware of it, be cautious of it. Know the system that you're dealing with. Take the time to read the service information, understand the test you're doing. What's the purpose of this test? What do I expect from this test if everything is working normally? And what do I have, right? If we can be confident in all of those things, we can be confident in calling a part. But that's where it comes down to testing to overcome that doubt in the call that you made. If you're just guessing at a part based on past failures, these sort of things are really going to throw you for a loop because you have nothing to fall back on. But the testing procedures, actually checking circuits, understanding what should be there, what shouldn't be there, and measuring it, that's where the confidence comes in. But heck, even then, it's going to make you second guess yourself when you get through with the same problem. But that's what we're up against out there. And hopefully this will put you in the right mindset when you're up against it with a vehicle with multiple failed parts. So that is all I've got for you today. Kind of a short episode, but we'll get some more interviews going here in the next few weeks. I appreciate everybody listening. I appreciate all the feedback. Other than that, let's get out there, start fixing the world one car at a time.